Okay, so it's completely crazy how fast the world is moving at the moment. It's just science fiction every single day. I think it was last week. Was it last week? Microsoft dropped something. They said they've been working on quantum computers kind of in the background for what? Was it 17 years? 19 years? I can't remember which it was. 17, a really long time. And they'd sort of taken a slightly different slant on it. I don't know anything about this. I'm not going to pretend to be a quantum computer genius or know anything about physics, but they were approaching it from a theoretical state of matter. Is that correct? Or no, from a theoretical particle, which had been theorized maybe 100 years ago.
It was both, actually. Yeah, both things.
Right, yeah. So I think, was it marijuana, something like that.
Not marijuana, that's something else. It does sound disturbingly like you could make a very easy Freudian slip there, though.
Yeah, right. So I think they were looking for. I guess they didn't discover it. They certainly didn't invent it. Maybe they discovered it, but it was based on a theory. They managed to stabilize this particle and put it into a new state of matter. So I said to my kids, you need to go to your science teacher and say solids, liquids, gases, and topological. I think it was called topological, which apparently is the way they've organized these particles, which enables quantum computers to work. That's all I know about it, and it sounds absolutely crazy. And it's brought us very, very closer than we've ever been before, to having a quantum computer that's actually useful and can actually do things. But on that very same day, the very same science fiction, the world has changed day, I saw a bunch of scientists. I think this was reported on the BBC, but they were working on, and have been working on for the last 10 years, a hypothesis to try and solve the superbug problem in hospitals. Now, superbugs in hospitals is all about antibacterial, antibiotic resistant bugs, right? So they get in and they kill lots of people and can't get rid of them, and they're antibiotic resistant. And they spent 10 years trying to come up with a hypothesis to try and figure out how they could solve this problem. And they were just about to publish their findings. So no, this is for peer review. Okay, so this is not public. And Google popped up and said, we've got this new AI agent thing. It's a bit similar to deep research, but it's very focused on science papers and science AI and science information. And he said, let's have a go at it, right? Let's have a go at it. And within 2 days, they came up with a set of 5 hypotheses. Now, you know how ChatGPT always gives you a top 5, right? So I'd imagine it's the same thing. You got these 5 hypotheses. The top one was the exact one that the scientists had spent 10 years finding. They found 4 others, 3 of which were ones that the scientists had considered. And the 5th one was completely novel. They'd never thought about it and has launched a whole new branch of research. I mean, this is absolutely nuts. Did you come across this?
I did, yeah, I did. It's quite amazing what can happen in a week these days, isn't it?
Yeah, I was reflecting on it and thinking, does this have a view or have anything to say about kind of the use of these kind of levels of tools with experts? So obviously these scientist guys, their reaction wasn't, I'm going to be replaced by this AI. It was, this is an incredible tool that I can now use to massively accelerate the research I'm doing. But is that because these guys are elite scientists at the top of their field who are like really excited about the tools? If they were juniors, would they be more worried? I'm not so sure. I don't know. What do you think?
I don't know. I think it's an AI problem in general, isn't it? I think the people at the top of their game can see the huge benefit this can bring, and it basically gives them superpowers and turbocharges everything they do. But for those more junior people in the workforce, and this is across all the whole of the industry, with regards to what AI is providing us now, that is going to be a much bigger challenge. How do you learn? How do you get to the point where you're able to effectively steer these AI tools and obtain those superpowers without first going through, the same kind of learning and development that the people at the top have gone through. And I was with a customer the other day trying to explain some of the stuff that was happening now with regards to the coding agents that are coming out and how software development is changing and how that's really, our industry, the software industry, is going through a massive amount of change at the moment. I think that the problem is it's a bit like driving trying to drive a Formula One car, right? If you're Lewis
I've never
Hamilton,
done that. I don't know what that's like.
I'd love to do that, but if you're Lewis Hamilton, right, you can go around Bahrain and you can put in a fantastic lap. You can nail every corner. You can have the perfect start. If you give the Formula One car to somebody that's never driven one before, they're probably going to stall straight off the start.
They're going to die, right?
They're not even going to get the thing going. And then once they got over that hump, they'll probably be able to go really, really fast down the straight, right? Insanely fast, but then they'll crash on the first corner. And I think there is a kind of slight parallel there with what we're seeing in AI at the moment. It massively facilitates the people that have all the learning and the understanding, and they're very quickly able to master those tools and feed it the right prompts and the right information to get the results they want. And when it goes wrong, or when there's they need to make that correction, they can do that very easily. If you haven't got the experience and something goes wrong, then you can end up spinning out or crashing, and it can take you a long time to get back to where you need to be. So, it's a strange journey that we're all going on at the moment, I think.
Yeah, that's a really interesting analogy, actually. You're right, because most people won't be able to start a Formula One car. Like, you say they can't get it going. And you kind of wonder how many people at this stage are, playing with the AI tooling that's available, getting very mediocre results and then just discarding it because they effectively can't even really start the journey because they haven't got the skills or the education or whatever it is to kind of get any meaningful results from it. I just hope it doesn't go to the opposite extreme where once you have got going, because you can't turn properly, you die. I mean, hopefully we won't get there.
Yeah, yes. Well, I mean, that's the crazy thing, isn't it, with this quantum computer? I can't believe it, actually. I was shocked that this wasn't bigger news. Like, when I saw this drop, literally within about 10 minutes of Satya Nadella posting something about it, I was like, what the hell is this? And I was all over the internet trying to figure it out. And I remember saying to my wife, actually, at the end of the day, this crazy thing happened today. This is going to be all over the news tomorrow. It's going to be massive. And it wasn't. It just wasn't. And it's still not really making the dent I thought it was. And back to what you said, right? There's solids, there's liquids, and there's gases, and then there's this other theoretical state of matter, which has been posited for many, many years in a theoretical sense. And most people thought, well, that's just too hard. That's only ever going to be theoretical. That's not the path that we're going to go down to figure out this quantum problem. And Microsoft took a completely different approach, very, very high risk. 17 years, so that was the longest running R&D project Microsoft have ever had. And they atom by atom created this new material, and it was a new form of matter. That's bonkers in and of itself. But they didn't stop there. They then went, look, you could do something really interesting with this. And you know how transistors, right? Before they were invented, essentially, computers were the size of a room and they worked off valves and all this kind of stuff. And now, I've got a computer on my wrist, and silicon has taken over the world and given us huge amounts of compute. That's only possible because of that breakthrough that happened with the transistor. Microsoft went, right, well, to scale quantum computing, we kind of need the equivalent, because qubits, they're really fragile and they get easily corrupted, and it's a really big problem. So after they'd invented this new state of matter, they went, I know, we can use this to create an entirely new type of topology, which is essentially, I don't know what they called it, a topological something like that.
Topological, yeah.
And it's essentially the quantum version of the transistor. So they've invented a new state of matter, a new material, or marijuana, whatever it is.
We've done someone an injustice here, because wasn't that the scientist's name that theorized that the particle existed?
And then they've managed to turn that into a building block, a fundamental building block, where they reckon now they can scale the qubits on a chip that fits in the palm of your hand to 1 million. They haven't done it yet, but they think that they can achieve that now within years rather than decades. And they've even, I think I even like followed the rabbit hole, and they've published the roadmap by which they expect to get there.
Yeah.
So I just think this is insane. I don't understand why it's not a bigger story than it is, because I mean, at that power that you would have with 1 million qubits, which is what they think you need to do stuff that's going to make a significant difference, it's going to change everything. It's going to allow us to simulate stuff, fundamental processes of nature. I don't know what it says for the future of cryptography and all the security protocols that we're using at the moment. Obviously that's been a big deal for a while, but I thought this would accelerate that conversation. It doesn't seem to have done that yet. So yeah, really, really crazy, really interesting.
And it's the pace of change as well. I mean, let's say this thing dropped on exactly the same day that we did 10 years of scientific research in 2 days. And you think, how do these things are converging as well? If you've got, let's say I don't know, I can't remember what the roadmap was, but let's say in a couple of years' time, we've got a working quantum computer that's got superpowered AI that's driving, I don't know, bioengineering. I mean, it's the way these things, it's all happening on the blockchain. It's the way these kind of brand new technologies that didn't exist within recent memory. So a lot of things we're talking about now didn't exist last year. I mean, the pace is crazy. But it's all coming together and converging. You kind of wonder where the next leap is and where it's going to be tomorrow.
Yeah, I mean, I've never known technology to increase at the pace that it's currently increasing. You just take a particular field, the one that we know most about, I suppose, is software technology and AI, and the pace of change and research and acceleration in the number of people researching it and developing on it, and the tools and developments that are coming out week after week after week. It's exhausting just trying to keep up with it all. Now that's just in our field, and I'm reading the Coming Wave at the moment. Don't read that if you want to go to sleep at night. But it's it's happening across the board in multiple fields, and we talked about quantum just then, but at that kind of bioengineering level as well, that you can buy printers that can print organisms and molecules and stuff, and they're becoming almost cheap enough for anyone to do that. I think it's still like 25 grand or something, or maybe a bit more than that, but insane, right? Insane that 3D printing was the big thing a few years ago.
Right. And that was just bits of plastic.
Yeah. I'm happier with bits of plastic, to be honest.
Yeah. Great. Oh, so yeah, I mean, pace of change, absolutely nuts. And that was fascinating. I mean, what have you got for me, Kev? What are you bringing? What was interesting for you this week?
What's interesting for me this week? Well, actually, this morning, Rob, I was really interested to find out about something that has been out for a while, I think, but it's only really just come onto my radar, which is diffusion language models. So everyone knows about LLMs. They're everywhere now. Nobody knew what the term LLM meant, a year ago, but obviously since ChatGPT and DeepSeek and everything else, everybody understands what the LLM is. Some people, I don't know, understand that they work essentially by predicting the next word. So you feed them a question and it starts formulating the answer, and it generates the first word, and it uses the first word to generate the second word, and it uses the first and second word to generate the third word, and so on and so forth.
A simplification, but yes.
Yeah, but predominantly that is how it works. Now, or not now actually. This has been the thing for a while, but there's a company that has just emerged from stealth mode with a rather compelling diffusion language model, and these work differently. So it sounds like a brand new term, but it probably isn't, because you would have heard of stable diffusion, right? Which is the image generation model.
Yeah.
And when you use ChatGPT or whatever to generate you an image, it's using a tool to do that, and the tool ChatGPT uses is DALL-E, right? And those image generation models are diffusion models, which means they start generating pixels, and these pixels change over time and turn into something that looks like the thing you want it to look like. And diffusion language That's magic too, yeah. But these diffusion language models don't work by predicting the next word one at a time. They predict a jumble of words. So you give it a question, it spits out a jumble of words, random words, and then it starts kind of gradually tweaking those words until they start making sense. And that apparently is a lot faster than the current LLMs we have at the moment, cheaper, because of the way it runs. It uses less GPUs and less processing and less electricity. And it can also produce more creative or nuanced results. So it's not, at the moment, I don't think anybody thinks that it's going to replace large language models, but I think that they will become something you'll hear more about, and they will run in parallel and be, excel at slightly different things.
Okay, so you're not saying this is something that's built on top of an LLM. This is an alternative to an LLM. Is that what you're saying?
Essentially, yes. It's a different way of producing the language than the current LLMs.
Right. Yeah. Okay. Because it's kind of the vision AI stuff is all based about identifying the next pixel. It's basically a very early version of what an LLM was based upon, and so this is kind of doing it in parallel rather than in sequence. So it's going back and checking its answers, or is it's just picking random? Because I get the serendipity, right? If it's bringing lots of random stuff together, probably not random, it's probabilistic, right? So it's bringing some probabilistic stuff together. Is it just because it's trying stuff that it wouldn't have otherwise tried, because it just takes the next most probable answer normally? I'm testing your knowledge here.
So when we write something, we probably write it much like an LLM. We are looking at, we got an idea in our head maybe, and we're writing it one word at a time. And as we're writing, we're probably thinking through and changing our approach as we're going. But nevertheless, we've got some kind of concept of what we want to write. We might even have, roughed out a skeleton or whatever. So I think LLMs are more similar to the way we would approach writing something. Whereas if you're, I don't know, let's say you're an oil painter, right? You might get your canvas and you might kind of rough out this stuff of big blocks of colour, and then you start refining that and filling in details, and the thing you've got in your head that you want to paint, or the thing you're looking at, it kind of emerges and comes into focus over time. And these diffusion models are essentially doing that with words. They're spitting out a load of stuff as an answer, which doesn't make any kind of sense, or maybe it's got kind of key words in there that it's figured out in its latent space, so it's somehow important, or maybe certain pairs of words, or even kind of fractional sentences, I don't know. And then it starts refining the whole blob into something that's more coherent and reads from left to right, makes sense.
So it's iterative, yeah.
It's iterative, yeah.
It's going back, yeah. And so is the outcome of this that you end up with stuff that's just higher quality, more reliable, happens faster, or are there kind of any kind of novel applications that you can sort of perceive? I'm struggling to see, other than pace. And it's going to write me a slightly better email than ChatGTP, is it? What's the bonus?
Well, allegedly it's more creative and more nuanced, because it isn't just predicting the next word; it's predicting words based on all of the context that they currently sit within, and that's getting refined and refined and refined. It produces different results, and I mean, from the small amount that I've read on it at the moment, it does seem that it's potentially better at stuff like creative writing, but I don't think it's better at writing stuff like code at the moment. So there are definitely strengths and weaknesses to both types of model.
That kind of makes me think about the whole agents conversation that seems to have really come up more and more in recent days, weeks. I mean, agents, I remember we were chatting about this last year. So imagine last year, 2024 was really the year that generative AI sort of went mainstream, right? So when did ChatGPT turn up? Was it end of the year before? Was it
2022 actually?
Right, end of 2022. But I feel like 2024, it really just kind of became alive and became normal, and everyone put AI on the end of their product, and it just meant it generated some text for you or created an image for you from a prompt. But I think maybe it was the end of the summer last year we started chatting about, well, this is not really what AI is all about. Yeah, okay, that's a useful tool. It creates some interesting results, but this agents thing started coming out of the ether and it stopped being theoretical. People started actually making some agent frameworks and some very basic agent tools. And now fast forward to beginning of February, end of January, beginning of February, you got OpenAI releasing agents like, Operator and, Deep Research as well, another example. So what made me think of that is kind of the coding thing and how the agents are currently operating on an LLM based approach. Do you think are they the way they're designed? Are they based on these kind of LLM systems, or can they move to this kind of diffusion based system, or are they completely? Is it more conceptual than that? Do you think?
They are based on LLMs, and they could move to diffusions, because ultimately, I'm not sure if this was obvious, if people saw this coming or not. I don't know, but yeah, when ChatGPT came out, it could write stuff and it could fake being a human really well, and it could explain stuff, and it could do some kind of reasoning in whatever the way it does reasoning. I mean, grab these ideas that it kind of understands and the context, and it can bolt them together to create entirely new theories and stuff if you wanted to. And that was fun. And people started using it to, help them write emails for whoever wants to spend ages writing emails. God knows why. But what was interesting is, because they could fake being a human, and because they could do some form of thinking and reasoning, and because the large language models were trained on vast amounts of data, including vast amounts of code, it turns out that two things. It turns out, one, they can write really good code, and two, when chain of thought reasoning came out, which is essentially just telling the LLM to just stop. And before generating the answer, just think step by step. So it kind of almost plans its thought process and then starts executing on that. And they took it like a slight step further. So behind the scenes, you've got, when in that chain of thought thing going on, you've actually almost got multiple personalities challenging each other on whether that's a good thought process or not. And that's some of the stuff that's going on in the kind of O1 models and the like. So when you bolt all that together, and you revisit some of these ideas from the go all the way back to kind of 1990s about agentic computing, they were very theoretical then. It turns out, yeah, we can do them now, and they work really well. And this concept of agents has come up, and so they're starting to be able to figure out how to find something on the web, or they're figuring out a plan of attack when they're going to go and research something. But the stuff that just has completely blown my mind over the last, got to keep pinching myself because it's not been that long. It feels like it's been ages, but 6 months really. We're talking from this wasn't a thing to now there are agents that can write really good code, and it's incredible. I've gone back to school, right? So I'm doing.
You're back on the tools.
Yeah, sort of. Yeah. So I've gone and started to do this course on agents by Hugging Face, just to make sure that I want to know how they work under the hood. And this is it's mind blowing stuff. It's incredible. So the way these agent frameworks sort of work is they use kind of an LLM almost as their operating system. They kind of. They're stuck in this loop, which is like, okay, you're an agent, your role is to do this. First step is you need to observe, and then you need to think, and then you need to act. Or maybe it's think, act, observe. I think it's think, act, observe. And so they're kind of almost, they're going down this chain of thought thing, right? So they have their first thought. That makes them decide to take some action. They take the action, then they look at the results from that action, and they figure out whether that was a good thing or a bad thing, and if it gets them closer to the answer or not. And then they have their second thought based on the observations of the first thought, and they keep going. Mm-hmm. Now, I've been looking at this particular kind of agent called Code Agent, which is on Hugging Face, and it's just crazy. It's crazy. It writes, it thinks about the problem that needs to solve, and then it looks at the kind of tools it's got, and it writes some code to try and answer that problem, and executes the tools, and then looks at the results to see if it's answered that problem or not. And if it has, it gives you the answer, and if it hasn't, it goes round again. And I was playing with this just last night, actually, and the agent was given the task, the code agent was given the task of, what was it? Coming up with a playlist for a party at Bruce Wayne's manor.
This is the task you gave it.
No, I was following the course material.
I was going to say, this is not a window into your mind.
I did kind of tweak it and play with it a bit, but I was mainly just following the course content. And the tools that the agent has available is a web search tool and some other kind of basic things about, what food's good to have at a party and this kind of stuff. Anyway, so the prompt that you're giving the agent, which is essentially just, underneath it's just an LLM, right? Is right, generate me a playlist for a party at Bruce Wayne's manor. The theme is superheroes. So it uses that query and it goes, and its first thought is something like, okay, I need to use my DuckDuckGo search tool to find out some ideas on what would make a good playlist, given that it needs to be about superheroes. And you can see its thinking and you can see the output. So it lists out, DuckDuckGo spits out a bunch of results on music, potential playlists and that kind of thing. And then it goes, okay, well, I've now got these results, so I need to pass these results into a list to present back to the user. And so it does that, and it generates that as code because it's going to execute something. But the code has a bunch of errors in it. It's generated the wrong code.
So it's generated bad code. It's generated
bad code. So it tries to run the code, but it can't. There's a compilation error, essentially. So the log outputs the fact that I got a quote in the wrong place. And so it can't run the code. And the agent goes round in its next loop and it goes, I've got an error. I've written some bad code. I need to adjust this code now to make sure it compiles. So it tries again. It gets it wrong again. And then it looks at the error again. And then it gets it right. So it's iteratively created code that works by understanding, by trying, failing, trying, and getting it right. Now,
feels quite brute forced. Feels quite brute force.
And that's the kind of thing I think that's a little bit weird, because a clever developer would have got that right the first time around. It wouldn't have made the stupid error that this thing made. But ultimately, it came up with the right answer. Now, I thought that was pretty amazing.
Yeah, it's crazy.
But also a bit weird. But the other thing that blew me away was it decided that actually that wasn't quite enough. It should go and interrogate the YouTube links from all of these playlist suggestions, so that I don't know why I thought that. So maybe because I could click and listen to the song myself. I don't know. Anyway, it tried to write some code to do that. It failed to do that as well. And so then it just decided, I can't do that, but I've got this list of songs, and they wanted it for the party, so I'll create a Spotify playlist. Went away and created a Spotify playlist. I was like, what the hell?
Wow.
Yeah, I mean, agents that think for themselves, they're weird. Yeah. They're weird. This is aliens. This is alien software. This is software that writes itself, and it doesn't write itself in the way that potentially you would write it, or have the same kind of constraints around your understanding of the problem versus its understanding of the problem. It's a very different world to live in. But it's fascinating. It's fascinating that it can do it in the first place, and it's fascinating that it can actually write code just to solve a temporary problem, and then essentially throw the code away.
And I guess these agents have different roles as well, right? So you're talking about here an agent that you've given a problem to, go and make me a playlist about this stuff. It's figured out how to do this playlist and even where to stick it so that you can use it. I mean, it's made a leap there to kind of be helpful. But I guess you could have an agent behind the scenes that's like checking that the playlist is still running or is active, or, effectively debugging it in real time, or, keeping it up to date because, the brand new Superman song has arrived. It's now number one. That needs to go to the top of the playlist. You kind of have this different role that's going on.
This is the ultimate destination, and these systems exist already. But when you want the better results and when you want a more complicated system, you break it down into essentially teams of agents that check each other's work. And I mean, you go back to where we started. It does feel like science fiction. But I'm watching this thing in real time, and I'm watching these agents write their own code and talk to each other and figure out what to do. And it's like, this doesn't make sense. It's software that thinks for itself, in whatever capacity it's thinking for itself, and more than that, gets together with its buddies and checks itself. I mean, this is out there right now. I'm experimenting with it right now. We're experimenting with it right now. And yes, I guess it's still early days, but you can't help but think this is going to radically change the way we think about software and what software is and how it works.
So how long do you think before we see a wave of startups that kind of effectively are building on the LLM application layer? I've got an idea, I've got this agent thing that's going to go and build the thing for me. It's going to design it, it's going to diffuse me the images, it's going to work out the UX, it's going to test it all in real time. I'm just going to give it a few prompts and let it do its thing, and it's going to pump out some SaaS product. When are we going to see, do you think, a wave of startups that are effectively building these SaaS products for them, kind of taking that early stage technical founder piece out of the loop?
I think if you know where to look, they're already there. Yeah, I don't think we need to wait. I think they're happening now. And when I say that, I mean they've popped up in the last 6 months. But they're definitely they're already working on those kind of systems, and you can see some of it even right now, right? The stuff, the way that these code agents work, and the way that things like Cursor and Bolt and whatnot, they're all agentic under the hood. I don't know how, if they've got multiple agents checking each other to generate you the kind of output that they want, or if it's just a single code agent that's working away. But yes, it's all happening, and it's happening now, and we're getting results, and good results that are getting better and better and better right now. But it does seem to be the domain of the Silicon Valley startups, and there's a few good ones in the UK actually.
Yeah.
But it's not, you don't see traditional organizations, I suppose, really doing anything with this yet, because this is still very cutting edge, and lack of understanding in the marketplace around the governance layers that do actually exist already and are starting to emerge already, such as explainability frameworks and agent ops frameworks and those kind of things, which allow you to dig in to the conversations that these worker bee bots are having.
We just don't know. We don't know what we don't know at this point. It's also new, isn't it? I guess, and so most organisations just have not got a clue as to kind of even where the tech is, let alone where it could go. A lot of people are still thinking about AI as generative text. Generate me this report, do this automation for me, update this row in a database. Thinking it much more of a workflow engine or a time saver because I've got to write less text than actually being autonomous. We can go off and do things for you. I guess it takes you back, doesn't it, to the initial conversation where we started with the Google co-scientist. Who was getting mega excited about the fact that this tooling was going to make them as very highly trained, high-level professionals in their field. Effectively, they're getting to a stage now, and they likened it to having their hands on a Champions League football team, and they were the manager now of a Champions League football team rather than a non-league football team. And so they're now orchestrating potentially these research agents to go and say, right, now go focus on this area, now go focus on this area, now go focus on this area, and doing lots of work which would either fall to a junior or would just take up lots of their time, and just be the orchestrator over the top. And I think, based on what you said there, you can see that happening in kind of technology world, particularly with new startups and new products coming to the market, that you might have an individual with an amazing idea or one very senior technical person who kind of understands how this thing should all hang together, orchestrating code agents to go and build the thing for them as they go.
This is a scary thing, I think, that nobody really wants to believe or to talk about too much, which is, if you've got the ability to have free thinking software bots that can put themselves in particular roles, and maybe even entire teams of them, and they can challenge each other and that kind of thing, and check each other, then what on earth does a company of the future look like? Because why do you need huge teams and huge departments to do stuff if you've got your senior department lead understands exactly what needs to be done and enough about how it should get done, that a large amount of those tasks can be delegated out to maybe what would have been junior employees, but are now these kind of automated agents. And it's hard to see how this doesn't have a massive impact on the workforce. And I don't know how you adjust the patterns within the workplace to allow people's careers to develop to the point where they're also the ones taking advantage of these new superpowers. So I think there's just a lot of things that we're going to need to figure out and work out. And we're obviously, our heads are kind of a bit stuck in the future, so we're kind of thinking about all this stuff. I think a lot of people don't really want to be thinking about this stuff.
Yeah. The kind of where the value sits for people is shifting. I think that's definitely true, and knowledge workers are really gonna feel that impact, right? You can see accountants, lawyers, wealth advisors, anyone that you would have gone to before, to use their knowledge and experience to then apply that to your specific situation, generate you some recommendations, or file some reports, or do some complex maths, or do something like that. You're just gonna need less of them once these.
Yeah,
once
I mean,
these
those people, their primary job was to know about a domain and to be able to communicate that to you. So that knowledge is now exists in these digital brains, right, which you have free access to, and you still want the human in the loop. It's not good enough to. There's no recompense if we're
not there yet.
No. The AI told me to do it. It's not gonna fly. But yeah, that I don't think the teams will need to be as big. You need the humans. You need that human relationship and that human governance, but underneath that, where you would have had maybe 5, 10, 20, 50 worker bees, I mean, it's going to be thinned out. If the domain is knowledge and understanding, and that's your currency, then those teams are going to end up being thinned out. I can't see how they don't.
Yeah, and this change is obviously going to happen pretty fast. In the grand scheme of things, I mean, it's not happening tomorrow, but in the next, we're counting it in months, probably, if not a small number of years, that we're going to start seeing the impact of this stuff. One thing I was thinking about was kind of how organizations need those innovators within their business, I suppose, within their organization, who are going to experiment and play and try these things, even though many larger organizations are going to be pushing back and almost a little bit scared of it, because that kind of change is difficult to deal with. We've seen this always over the years. We kind of shadow IT, people doing stuff off their own back, playing with whatever was the fun new technology that was interesting at the time, whether it was, I've got this exciting new email client I want to use, or this is my favorite word processor of choice, or in our world it was engineers. There was always an IDE, wasn't there? If a team of 20 engineers, you guaranteed there'd be 15 different IDEs or plugins or whatever they could use, and wasn't involved. And again, on our journey, we've seen this to the kind of the nth degree, where you kind of go into an organization and some really bright spark, clever individual, built an automation engine out of Excel and VB script, and somehow 15 years later that guy has left, but it's running the entire invoicing billing system for a multi-million-pound company, and no one dares touch it. So I think we're going to see, interestingly, I think we might see with some of these tools that kind of thing rising again if we're not careful. We saw it again recently with Power Platform, and we talked about organizations. We talked with organizations about their citizen developer programs and how you put wrappers around this kind of stuff. But surely now with tools like Cursor and Bolt and others, where you can start to build stuff or play with stuff with a few prompts and a smart idea, you can actually generate quite complex applications relatively easily, moving systems around, testing, I guess, the limits of the current security structures, because maybe the individual's got access to some data in a database, but you're now giving that access to your application that you just knocked up with a couple of prompts. What's it doing with that data? How's it mashing those things together? And how do you control these things once they've been built? And so I was wondering, is this what do you think? Is this a new level of shadow IT? Are we gonna, and should it be encouraged? Because organizations need these people to be tinkering. What do you think?
So you think? So I think I get what you're going with. So yes, in the early days, people did terrible things with Excel macros, right? And just abused them to create entire applications.
You said that with like death in your eyes. It's like terrible.
I've seen some horrendous things. And then you have these low code tools. And Microsoft actually with the Power Platform, the whole push was around the citizen developer, wasn't it? The problem with that is it's just a nicer way, or if you're not careful about it, it's just a nicer way of creating awful Excel macros at a scale that they should never have been allowed to get to.
Yeah.
And we've worked with organizations where they've used the Power Platform and ended up in just a mess. All these small applications have been built and are being used, and then the person leaves, and there's no formal process, no support around it, nothing. You've got 10 different applications all basically doing the same thing but in slightly different ways. You've got no data governance, you've got GDPR problems. It's all happening off to the side of the main IT policy and the checks and breaks and that kind of thing. But I guess your question is, are we going to see that, but like on speed, I suppose?
Kind of. I imagine a world where you're back in the workforce. You're a worker bee. You're working for a big organisation, and you've got a job to do. Right. This was in your distant past, but it was part of your past. And I've been there too. And there was a thing that you just kept doing. And it was annoying. And you'd write a little script to speed it up for you, because that was kind of how you were wired. You'd use the tools that were available, whether it was, I don't know, some people would use a mail merge to do lots of emailing out, and then they'd like build that into an Access database, because that's where all their contacts were stored. And then they realized that they could tick a box on the GUI of the Access database, which would then trigger the whole thing off. And then all of a sudden they've connected it to their invoicing system, which is in Excel. And you can just join all these dots quite easily, and you end up with a mess. And you're having a great old time, because you're stretching your brain, you're learning new things, and you're playing at the edges of your understanding, and you're saving time, and you're getting rid of some of the work that you hate, and your boss is happy because it's all getting done and it's all super efficient. So now translate that into a world where you've got a prompt-based development engine, and those are going to become increasingly, I would imagine, more friendly. At the moment, they're very, very geared towards engineers, and engineers writing code faster, right, and scaffolding stuff and the rest of it. Oh, these are going to get windows on them, which basically say, "Tell me what you want," or "Feed me your sketch." And there's already some examples of that where you feed it a sketch and it will pump out the web pages for you. So I would be using those. I would be in there playing with them, creating mayhem probably with whatever systems I had access to, just to make my life easier or more interesting. And so I'm thinking, I'm not alone in that. And there's got to be a lot of people that have started playing at the edges with products that are not authorized. And I imagine the IT team don't even know they exist, half of them, particularly in a non-technical organization. There's a wave of carnage coming, I think, from shadow IT and citizen developers here.
I guess potentially, yeah.
We'll wait and see. Well, on that bombshell, I think we're probably done. Have you got anything else you want to chat about today?
I have got a bit of.
Do you want to do one more?
Yeah,
we can do one more. Let's do one more. What have you got?
So I've been down a whole rabbit hole with this, LLMs and reasoning, and I think I was in the camp that was very much, look, these aren't just word calculators, there is some kind of reasoning going on here, and I still think that's true, but I think I probably gave it too much agency. I think I probably attributed an ability for it to reason beyond what it really is doing and what reasoning really
it's sort
means.
of faking it, right? It's a bit of an illusion what it's doing at the moment, because it's so probabilistic rather than at the end of the day, it's largely based off statistical patterns and correlations within its training data. And it's, that I don't want to belittle it. What they do is still amazing, because they essentially build a library of concepts, if you like, in these digital brains, and so they understand that this particular thing is a bit like this thing, or is somehow related to this thing, and so when they're spitting out these words and ideas, they're pulling on a
and making connections between all these things. And sometimes they're connections that we wouldn't necessarily make as well. So I think they are fundamentally very, very useful, but they're not us. They don't think like us. They don't reason like us. And they don't fall back to doing some really obvious things that we would fall back to doing. So they've improved that reasoning ability by introducing chain of thought. And, all the models now are thinking, which just means they're trying to figure stuff out step by step and plan an approach rather than just spitballing.
Yeah.
But it's not really good enough in terms. If your goal is to create a more and more intelligent system, it's not really good enough to rely ultimately on statistical patterns and concepts and obviously a vast amount of knowledge to arrive at the answer, because quite often you need a lot more rigor than that. And so I went down this rabbit hole with kind of reasoning and what was going on and what people were doing to try and solve this. And in my head, anyway, I kind of thought, well, is it a bit like the human brain, right? Do you need an LLM that has multiple bits? So you've got your prefrontal cortex, which is your language model, and it's interpreting stuff, but you've also got this bit over here, which is a bit more creative. This bit over here, which is, I don't know. I'm not a brain.
It's a good model. It's an understood model.
Just go with me for a second. And actually, so when I started exploring this idea of a kind of more modular AI, or hybrid AI, is now sort of emerging and is a significant field of research. And I think it's DeepMind. I think it's still Google DeepMind have made waves with this recently as well, because they're working on an AI called Alpha Geometry. And earlier this month, I think they released version 2 of that. And the reason that Alpha Geometry is interesting is because it's what they're calling a neurosymbolic reasoning model.
Okay.
Which means it mashes two things together. It mashes the neural net, which is the fundamental architecture behind LLMs at the end of the day, and it combines that with a formal reasoning module.
Mm-hmm.
So it's getting the advantage of the kind of fast thinking, and then once it's figured out an approach, it can use its formal reasoning to go through something a bit more, very rigid in terms of a process of logical deduction.
Right.
And if you think about it, where as humans we've got two modes of thinking, fast thinking and slow thinking. And this is a model that can do both of those things. And, it is intelligent to know when to solve a problem using formal methods. Like when we're doing, trying to answer my son's tricky maths problem. At 10 years old, this was a very tricky maths problem.
Honestly, it's got harder, right? The levels have changed.
And actually the way that they wanted them to answer it was probably not this, but the way that I approached it and failed miserably was a simultaneous equation.
Yeah, that's 10-year-olds are still not doing simultaneous equations, mate.
No, but this was a classic problem that should have been solved via a simultaneous equation. And like my wife is brilliant at maths, and so is my son actually, which is probably why I got asked this question. But they just saw the number, right? They saw that was a factorial of that, and therefore it must be this. I think my son's approach was just like, I tried all the numbers until I got the one that worked.
Yeah.
And my wife's approach was like, no, I just saw what number it should be. And so that was kind of fast thinking. They were almost approaching that from the way an LLM would approach it.
Mm-hmm.
But when I looked at that, I was like, oh, I can't see numbers like they can see numbers. So I know how maths works, and I know this is a simultaneous equation, and I know that if I put this thing up here and this thing down here, and I've got two equations, and I can solve one by solving the other, and that's the formal mechanism you go through to get to the answer. And so there's a process of doing that, which because I haven't been at school for a very long time, I felt was to do. But the approach was correct. And that's the thing. So if you know there's a formal method for doing something, you want to be using that. You want to be using that logical, rational, deductive process.
Mm.
And I think that's where, I think there's got to be some kind of nod to that in all the stuff that's going on with AI at the moment, because we've put huge amounts of resource and money into scaling LLMs by giving it more and more data. And that's all you hear about. We need more data and we need more compute.
It's the 2000. How do you solve the problem in the year 2000? Well, you give it more RAM,
Yeah,
more memory, and more RAM. There you go. You made your computer.
but maybe actually it's different modes of intelligence that we need, and we need fast thinking and slow thinking, and so I think we'll see a lot of these hybrid models. I think that will evolve. I think it'll have to. I think on that kind of hunt or race to AGI that everyone's talking about, I think we are going to move beyond just the current reasoning, this chain of thought reasoning that we have developing in LLMs at the moment, into kind of maybe a more modular looking AI system or an evolved LLM that has other means of intelligence at its disposal.
Do you think so? I don't know if you remember a couple of weeks ago, we had a little experiment with ChatGTP. I can't remember which model it was. I think it was O3 Mini.
O3 Mini High.
O3 Mini High, because that was a thing at the time with reasoning. That's probably moved on a bit since then. We wanted it to play rock, paper, scissors, right? And we got ourselves into a bit of a mess with this because originally it just cheated, right? We was like, we want to play a game of rock, paper, scissors, and you need to try to win. So it just played the game, except it hadn't made the connection that you have to reveal the answer simultaneously. So originally it just always won because it said, oh, what are you going to do? Okay, I'm going to be scissors. Great. I'm going to be rock. I win. And so then we have to kind of take it on a journey through, well, no, you're always going to win doing that. And, so now you need to think about how do we do a simultaneous reveal that's fair. And it went into ciphers and all sorts of crazy stuff to, encode it. And then even then when you look back through it, certainly on my version, it was still cheating. It was just looking at my answer, then changing its answer and then re-encrypting it and presenting it back as I hadn't cheated. But so there's a long-winded way of saying, do you think that kind of problem would be solved because it was, or would it still just never get past the short term? It's like,
that's
I think I can solve this quickly,
because that's
so I'm
not
cheat.
having to go through a formal reasoning. I don't think it's going to have like a geometry maths problem or simultaneous equations or whatever. But there is a form of reasoning that doesn't seem to, it doesn't have. Because I played the same game with my 8-year-old daughter. And I said, right, let's play a game of rock, paper, scissors. You go first. And she just looked at me. And she's like, oh.
Right.
So why not? I said, well, because then you'd know why you had and you'd win.
Yeah.
So she got that straight away. But the LLM goes, yeah, great. Mine goes scissors. And then you go, okay, rock. And he goes, wow, you won. How did you do that? and then even when you start, that whole thing of kind of, can we develop a prompt without giving the game away, that gives it enough information to come up with the correct answer off the bat. And I thought, I do remember this, and I thought that I managed to hone this. And one of the key ingredients was this must be a fair game.
Right.
For whatever reason, that the LLM would adapt its thinking process if it knew that the game had to be fair.
You didn't want it to cheat.
Now, I used temporary chats to make sure it didn't have any kind of history or memory or any of that kind of stuff. And this was so frustrating. The first time I asked it and I used my newly formed prompt, it correctly goes, oh, well, I can't just... Okay, I used to say, no, I've got to go first. Right, so it has to be fair. Okay, so I am going to think of the thing that I'm going to, my rock, paper, scissors, and I'm going to think of the seed and I'm going to encrypt it and I'm going to show you my encrypted answer first. And then you tell me what you want, what your answer is, and then once we've got both answers, I'll decrypt my answer and we can see one. And that was genius. So I thought, I've cracked it. Right, this is it. So it's not as stupid as we thought. But then I did exactly the same thing again in another temporary chat, and it just said, yeah, sure, I'll go first. Scissors.
Yeah, I know. Makes no sense. And also, you've painted an incredible picture about what our days are like. We spend the day playing paper scissors with various AI engines.
Yeah, living the dream.
Living the dream. Fantastic. Well, I think that's it. I've got nothing else. If you got anything else, you got nothing else, then that must be the pod.
Sounds good. Till next time.
Till next time.